Hi, I'm Shi Chaoyang, and today I'm going to introduce my study about the follow-up Dunder's experiment, and the particular part I'm studying about is the influence of the reverse reaction required situation. So to begin with, in Dunder's original experiment, he's studying the choice reaction time, and I realized that in his experiment, the light and the key pressed are on the same direction, which means that if the left light is on, you need to press the J button, and if the right light is on, you need to press the K button. And I'm thinking about what will be the result and situation if the required key is in the opposite direction, which means that you need to press the K if the left light is on, and instead you need to press the J if the right light is on. So for the assumption, in Dunder's original experiment that there are actually three steps. So the first one is when the lights will on, and then you made the decision in your brain, and then you press the button. And I'm assuming that there is an extra situation happen that after the lights on, you need to first flip or reverse the situation, which means you need to identify that you need to press the opposite button, and then you made a decision, then the button is pressed. So the reverse situation might take more time than original Dunder's experiment. The method I'm using is that I made a app that doing both the three experiments. So the first one, it will start from the original simple button, simple lights one that you press the button when the light is on, and this is indicated by the white circle. And the second one is doing the Dunder's choice reaction time task, which is that you press the left button when the left light is on and press the other button when the right light is on. And this is also indicated by the white circle with a left and right difference. And the third experiment is what I'm studying about, is the reverse choice reaction time task, and which are indicated by the left and right circle. And participants will be told that when you see the white circle, press the button left or right when it's on the each direction, and if it's in the middle, just press the left button. And then that if it is a red circle, that press the opposite button. And each experiment will repeat for 5 times and 2 seconds interval between each, and the results will be shown at the end of the experiment, both the accuracy and time. So the accuracy is also showing because that we might want to see that if when the action is in the opposite situation, that not only the time is a consideration, and also whether the participants doing the right decision. And here is a link for the experiment that you can do it online. And here is a video for an example experiment that I do it myself. And here is the result of this experiment. The first line is the first experiment, and the 5 times for each, and then the average. And then these two lines are the second and third that both have a true false situation indicated that participants doing the right decision or the wrong one, and then following by the time, and then there is the average time at the end of the line. So for the results, and this is an experiment that I did myself, and they actually showing the assumption is correct. And you can see that the time span is being longer and longer for from the first experiment to the last. And then I realized that as I'm the designer and who made the app, that I might be familiar with it. So it might be not trustworthy that if I do the experiment by myself, so I recruit another participant to do the experiment. After I make sure that the participant knows how to do the experiment and what is the situation. And here is a result that actually showing the results of the what is the participants doing. So it also follow the assumption, prove that the assumption is correct, because each experiment is spending more and more time. And then consideration come into my mind that as the time between each experiment is the same, I'm thinking about whether the brain that might be trained to do the reaction, which means that the brain will realize that after 2 seconds, a button will need to be pressed, and the brain will get ready to see which light is on. So instead of the 2-second time interval each, I change it to a random number from 2 to 4. And here is the result for the random time interval one. It also follows the assumption, and by doing this, I can make sure that the time is not actually influencing the result. And for the conclusion, actually, as you can see that the result from each that first of all, that original Donder experiment is proved to be true, that when you need to decide to press the left or right button, it actually take more time than only press the button when you see the lights on. And for the reverse input situation, as it's taking more time than Dunder's twice reaction time test, which means that it actually spends more time when you need to press the opposite button. And so this proves that there is an extra step between the original Dunder's experiment. And for other considerations, I'm assuming that the situation about the same experiments, which means that between two lights, if the first one is on the left and the second one is also on the left, that your brain might be trained to do the same reaction. And if this happens for several experiments, the times you spend might become faster and faster. And as my design doesn't include whether the two near or neighbor experiments are the same situation, but here might be a hint about the situation, which means that it takes 0.5 seconds for the second and 0.4342 for the next two. This might because that it is they're happening the same day, which means that either the lights are both on the left or on the right. And to avoid this, the more experiments may need to do. So for example, like 10 instead of 5 for each situation or each experiment. And also can make a better design that the results will also included that whether two or the neighbor experiments or the near experiments are in the same situation or not. And I'm also thinking that this might be shown by if the time span is getting faster and faster, and suddenly it goes wrong. The result of the participants is wrong because that they are trained to press the same button, but suddenly the situation changed, so you are still pressing that button, but actually that's doing the wrong thing. And that might be proof if this consideration is happening. And also it needs more participants to do the experiment in order to make a more trustworthy result, because like now there are only one participant doing this. So maybe in the future experiments, more participants will need to include it to make a more trustworthy result. And that's all for my presentation, and thank you for listening.